This Week in Radio Tech, episode 176, is brought to you by the Omnia 9 FM and HD audio processor with Undo for audio that's actually cleaner than the original. On the web at omniaaudio.com/9.
And now, our feature presentation.
Twirt.
On location from the SMPTE Conference and Expo at Darling Harbour in Sydney, Australia. The experts are lined up and ready to go.
All right, calm down. He says that to everyone.
This calls for immediate discussion.
What's up, Doc?
All your days are belong to us.
From his palatial office of important business,
or in a choice hotel in a distant land.
This is Kirk Harnack.
Chris Tobin is in studio, and I'm talking with Tom King, Jay Tyler, John Abdnour, Goran Tomas, and more.
You're dialed in to This Week in Radio Tech.
Hey, welcome in. It's time for This Week in Radio Tech. I'm Kirk Harnack, your host, and where in the world is Kirk Harnack today? Well, I am down under in Sydney, Australia, at the SMPTE show. That's hard to say, SMPTE and Sydney in the same breath. Hey, as usual, with us, the best-dressed engineer in radio, Chris Tobin, is in studio. Hey, Chris, how are you?
Hello, Kirk. How are things down under, as the phrase would be?
We are awesome, and I'll tell you what, you always give us a brief New York City weather report. I got to tell you, it is gorgeous here. It is just, the humidity is low. It stopped raining before we got here. And Sydney is just a beautiful city this time. Well, any time of year, but I mean, it is really nice right now. They picked a great city and time to have this event. You could eat outside. It's kind of like a nice European city in a cool summertime setting. It's just awesome. Wish you were here.
Oh, I like that. I like that setting. Well, I can tell you here in New York, it's in the 70s, low humidity, overcast skies, no rain, very comfortable, and much better than what we've had in the last 2 weeks.
Oh, good. Well, it's good all the way around. Hey, well, let's get right into the show. I've got a few interviews set up on This Week in Radio Tech here live from Sydney, Australia at the SMPTE show. And first of all, I have with us Michael Day. Hi, Michael. How are you?
I'm well. And yourself?
I'm great. Now, you know, this podcast tends to be geared toward radio engineers.
Yes.
And in the U.S., we know of this organization called SMPTE.
SMPTE, yep.
But not every radio engineer knows all about SMPTE. So tell us about SMPTE.
Well, SMPTE is the Society of Motion Picture and Television Engineers. And I'm a television engineer. But if you do know of it, you probably know of it from the standards. And that's what we're heavily geared towards, the standards, which is heavily geared out of the US side of the association or society. But there are also other parts of what we do, and that's more around education. And the networking aspects. There's a whole lot of sections, like us here in Australia, that do get involved in the standardisation of what we do, but we also get involved in the social aspects, and we get heavily involved in the education, whether it be ongoing education for your professional, whether it's trying to get people into the industry and find that job and get that first step up into television or film.
You know, it sounds a bit like I'm pretty well involved with the Society of Broadcast Engineers in the States. So SMPTE sounds like
very similar.
What has become popular in Australia for similar purposes.
Very similar, very similar. I mean, your core organisation is the US based, and ours is too. So, but we just happen to be a remote satellite and do things here for the industry locally within the umbrella of the US Association.
So now, in the US, the big show tends to be the NAB show, which now also I believe does include some activities from SMPTE.
It does.
And maybe not IEEE, but AES may do a few things. Yep. The RTNDA does some things there. So in Australia, this seems to be the big show.
It is the big show. It's the biggest and probably the equivalent to NAB for the US. I mean, we're obviously a much smaller population, so the show is scaled appropriately, but it's very similar, yes.
Would you have any idea of the number of attendees or exhibitors, any stats like that?
We regularly get about 7,000 people through. I mean, this year would probably be a record. We're heading for 7 to 8, maybe 9,000 if we're lucky.
That's amazing. I've met about 5,000 of them.
Yeah. So no, this year seems to be a really good year for us for attendees. As for people on the stand, stands here, I can't recall, but we're full, so we're pretty happy about that.
Good deal. And about any idea how many manufacturers and vendors?
I can't recall. I'm sorry.
Now there are some white papers and presentations given, right?
Yeah, we have a 4-day exhibition and a 3-day conference. So the conference has just concluded. That finished yesterday.
I noticed that for the first couple of days there was another expo going on here. Yeah. What was that about?
That's more around the staging people, so live production. Out in the field, we tend to deal more with the broadcasting or film or the back end heavy production aspects or broadcasting perhaps. Whereas next door, the trade show next door, which we work together with because of the obvious synergies with the groups of people, quite a crossover. They're more to do with external productions, so out there in the field.
But not much call for disco balls on the news set on a TV station.
No, but it's kind of fun, and we have done things like that in the past. But that's more for show, not for the real thing.
So if a person is interested in broadcast television engineering, SMPTE stands for what?
So the Society of Motion Picture and Television Engineers.
If someone's interested, how would they get in touch with a local SMPTE section?
The best way is to go to the website, which I think is smpte.org, or Google, and you'll be able to see the home website. And they've got a list of local branches everywhere from Australia through to UK, India, and of course all over the US.
Gotcha. I'm in Nashville, Tennessee. I want to say that in Nashville, AES and SMPTE are combined into one group of people who meet.
That it does happen. It depends on your body of how many people in the respective groups, but they do tend to cluster together. And we work very closely with AES here in Australia as well, because of the commonality and the camaraderie, so to speak. So. Yeah.
Michael, thank you so much for stopping by. I really appreciate it.
No problem at all.
Thanks a lot, and good luck with the rest of the show. Today's the last day.
It is indeed.
It's casual day.
It is indeed. That's right. It's great.
I didn't get the memo. All right. Thanks again. All right. You're watching This Week in Radio Tech live from Sydney, Australia. That was Michael Day. With the SMPTE. He's on the SMPTE board and talking about the show. Let's bring in John Abdnour. Am I saying your last name right?
You're saying it perfectly.
I have.
Not many people do that, but
you and I probably didn't meet until the last few years, but I remember getting newsletters from you or with your picture years ago. I mean, when I was like a swaddling baby.
Are you saying I'm an old man now? Is that what it is?
When you were with here, let's put my earpiece here. The cord is too short. Let's pull up a little bit. Right. So yeah, when you were with Continental.
Continental was, I started with Continental Collins in 1979, and Continental bought Collins in 1980. I thought you were going to say,
and you were fresh out of high school when you started with Collins.
Thank you. Yeah. Just about. I thought you were going to really date me and say you first saw my pictures when I was with ITC, the cart machine people back in the 70s.
You were with ITC? I didn't know that.
I was. Yes.
I loved ITC. You know what ITC did for me? We're talking about a cart machine company, International Tapetronics Corporation, and they made the Haas workhorse cart machines.
They did, of the cart machines, probably the best that were ever produced.
And I could never say enough good things about Michael Beauvais.
Right.
And I have no formal education in electronics. Michael Beauvais taught me how transistors worked by telephone. We're both looking at the manual. And he taught me all about electronics on the phone.
ITC is a company that goes back, let me think, they started in, I think, 1969 or something like that. I went to work for them in 1974, 75. And it was a wonderful experience. It was a place where they built a wonderful product, and they really knew how to take care of customers, and it was a great education because many of us that worked there carried through with what we learned there for the rest of our careers.
Yeah, for me too. Yeah.
Right, exactly. It's a good place.
Learned about pinch rollers and solenoids.
Pinch rollers and, exactly.
Yeah. And when to replace capacitors. So we sure did a lot of that.
Make sure to replace if you're using a cart machine today, and I wonder if anybody in the world it probably needs to replace the capacitors. You're right, Kurt. Yeah.
Now, you're not wearing an ITC or a Collins or a Continental shirt right now. You have a Nautel shirt on, and Nautel, what a great transmitter company to work with.
Really, they really are. We really are. Let's put it that way. Nautel is a company that's been was founded in 1969, first building beacon transmitters for navigation.
Nautical electronics.
That's correct. Then moved into medium wave AM and continued on from there into FM. And today is, I think, the leader in solid state, in medium wave and FM broadcast transmitters. We do a remarkable amount of business in North America and around the world, and we're quite proud of our products and our people. They've done a great job.
I wouldn't for a minute belittle any other transmitter company. There's plenty of people making great solid state AM and FM transmitters. But one thing that you find out about working with Nautel is that you guys really seem to, you get a feeling of you're going to be taken care of. If you have a problem, it's going to be fixed. Just work with us and we're going to take care of it.
They've always, the company's always worked on that pretense. They've always felt like we have a responsibility to take care of the customer. Once they buy a product from Nautel, they can depend on us to take care of their needs. So we still offer service, I should say, on the first transmitters we ever shipped from 1969.
I was just thinking, on this show, in previous episodes, we have done a video about replacing a blower in a what's essentially an RVR transmitter.
Right.
And for those of you who have been with watching our show that long, you can go back and review that episode. That transmitter is no longer there. It's been replaced by a Nautel.
We've been very fortunate with the replacements of business that we've had over the last good number of years, and we've got a great. And the reasons are manifold. Great product line, great people that we have working with us, and of course the respect of a great industry.
Let's chat about the technology for a minute. I mean, it's not supposed to be an hour-long commercial. Nautel is doing some very interesting things with high tech in the exciter, in the FM exciter, right, to give you some really interesting options that normally took place outside the exciter.
Right. We're doing a lot of things. First of all, the basics are the built-in things that many of our brothers in the industry have with built-in RDS, built-in stereo generators, etc. We now in our newer product line, our VS series and our NVLT series, can include an audio processor board that is built into it and accessible by web. But one of the things that we've developed within the last year with Omnia, and now it's spreading to all of the other audio processing companies, is what we call a direct interface, where we go directly from digital output of the audio processor to the digital input of the exciter, and just eliminating any conversion.
And this is over AES 192, right?
Correct.
So it's 192 kilohertz sampled AES, digital audio. And this is a sampling of not the left and right. This is a sampling of the stereo baseband.
Of the stereo baseband, that's correct. So we just get rid of a transition stage, if you will.
So what is significant about this is the processor company, in this case Omnia, performs all the audio processing in the left and right domain. Then we run it into, because I do work for the folks at Telos Alliance and Omnia, we run that into a digital stereo generator. So we digitally make this the stereo baseband. The left, we've had an episode on explaining this, the left plus right, the stereo pilot, the left minus right, either single sideband or standard dual sideband. And this is, it's still all digital in that it's an AES, very high speed sampled. When it goes into your exciter, what is different about this than what we used to do?
We take out the baseband out of it, and it's a digital stream all the way into the to the DSP of the exciter.
This essentially, I'm sure there's a little bit of massaging, but it goes into the numerically controlled oscillator.
Correct. It does.
So there's no places where any bad things can happen.
Right.
To the signal.
That's all been removed.
Yeah,
that's all been removed.
Remember, we used to deal with AFC bounce and things like that with FM exciters, and so the differences in some ways are subtle. But when you add up all the subtleties into a perfect stream, what do you get?
It's just a much cleaner sound, and you get rid of all of those artifacts that were in there before.
What I think is interesting is that it's cleaner, and we as engineers oftentimes don't realize that we have a problem because we've lived with it all of our careers.
That's correct. And once you clean it up, you think, my gosh,
how did we put up with AFC bounce before? And now we don't have
it's a cumulative effect. You have a little bit of this, a little bit of that you correct over the years, and when you put it all together, it's pretty major. Wow. And this is major.
Yeah. So there's probably a paper, a brochure on the...
there are on our website. You can find at our website, and I think Omnia's got one site too that people can look at. Just go to nautel.com or omnia.com and you can read about it.
Are we called, at the moment, this is branded as Omnia Direct? Or
right now it's called Omnia Direct. I know that it's available. It's going to be available with all of the other manufacturers. So I guess we'll have to come up with a new name.
Well, and we're not really doing anything that's proprietary. It's just it's a great application of an existing technology.
It is, and to make the industry better, it's available to everybody.
Yeah.
So it is. It's great. It's a great technology.
John, thank you so much for taking the time. I appreciate it very much. John Abdnour with Nautel. They're one of the exhibitors here at SMPTE, the Society of Motion Picture Television Engineers Expo here in Sydney, Australia. Hey, Chris Tobin, I've been doing all the yapping here for the last 15 minutes. What comment might you have for us while we bring in a new guest?
Oh, I was just curious. How anything new where you are in the expo? Any good stuff? Anything we should be expecting to see later this year?
You know, Chris, I don't know that I can answer that. I haven't spent a lot of time at each stand. The Omnia Direct that John just talked about was a technology introduced at the NAB show just a few months ago, and so it's kind of new at each show that people are talking about it. And this show is so much television. I mean, if you love visual excitement, there's so much, like Kid in the Candy Store. here, with Avid and Blackmagic and just so many companies doing video. That's amazing stuff.
Well, that's why I thought maybe you may have caught your eye on something. That's all, because I know it's a TV, very visual event.
We're gonna backtrack from from video to a technology that's been around for 100 years, but it can always get better and always be more reliable. And so I'm standing here with Tom King, famously of Kintronics. That's a company that, man, I've been dealing with for. Hey, Tom, why don't we step forward a little bit? Because my cord is just too short here. I'm gonna pop this out of my ear. Tom, you run Kintronics, yeah?
Yes, sir.
And tell me just a couple sentence history about this company. What does Kintronics do, and how did it get started?
Kintronic Labs was started by my father, Lewis King, in 1949 when he came back to his hometown of Bristol, Tennessee, having worked for RCA for a number of years in high-power transmitter design and other areas. And he came back and started in 2 offices that my grandfather gave him in his real estate office. And that's how he started. He got his PE license in Tennessee and Virginia and started a broadcast consulting business, and then a few years later started manufacturing. And then in around 1977, he went fully into manufacturing and discontinued his consulting work.
Now, most everything that Kintronics does has to do with AM broadcast band and shortwave, yeah?
No.
No? Oh, tell me more.
No,
I stand alone.
We have products that, we're known for AM radio. There's no question about that. But we do provide products related to FM, co-location of FM on AM towers.
Oh, sure, okay.
As well as FM patch panels, rigid transmission lines. And also we make a lot of isolation transformers for DVB-T, for mobile TV, for wireless hotspots, and a variety of other applications for installation on AM towers. And then we also work on ELF, VLF, submarine communication systems. And we work on systems for telecommunications.
You probably work on things that you can't tell me about.
That's right, as well.
So, sometimes on a podcast like this, where we're streaming over the internet, we get comments in the chat room from time to time that AM radio's dead. In fact, radio's dead. And every time I meet up with you, I hear some exciting story about some great AM or shortwave project that you're doing that I think it is not dead. There's still millions of listeners to broadcast band and shortwave around the world.
That's right. And I think the biggest thing that you can say about AM and shortwave is it is over the horizon in terms of propagation characteristics. AM, of course, at night, and shortwave, depending on the polarization, could be day and night. But that's the thing I think that is one of the unique things about AM radio. When you think about those broadcasters, such as major international Christian broadcasters that want to be able to broadcast into closed countries. And AM radio is one of the ways to get there. And then I think also with the advent of HD and DRM technologies that are now being embraced by specific countries and are also under test in a variety of countries, that and as we see receiver developments coming along in concert with the transmission developments, that seems to be maturing technology. And I know just recently the Europeans acknowledged DRM and DAB Plus as recognized terrestrial media. And we're very thankful to be involved with Nautel in the rollout of DRM in India, working with them on 27 different sites.
So they're taking what used to be AM analog transmission sites and making them into this digital radio mondial, DRM.
That is correct. They're upgrading existing sites all over the country. And these are 100, 200, and 300 kilowatt sites.
Wow, wow.
So it's a major development.
But what you hear from the receiver is a coded signal. I mean, what you're getting basically is what AAC encoding of the audio transmitted digitally and received on a radio.
That is correct.
Yeah.
And it's there is a simulcast DRM format, in which case analog would be broadcast on one channel and DRM on an adjacent channel.
Ah, okay.
Now you've got to have, of course, dual channel spectrum allocation for that.
Sure. Now DRM, when received on an AM radio, sounds like what? A bunch of noise?
Yes, it's you're not going to hear anything.
Yeah.
It's going to be unlistenable as far as anything you're going to hear on an analog radio.
I think DRM's a very cool subject. I'm glad to see India making use of their spectrum and high power facilities to make that work.
Yes, and I think as they see that unfold and others see the consequences of it, because you have not just audio service, but you have data services that you can also add to that. And you can narrowcast and hit, go for particular audiences with particular program format.
Mm-hmm.
And you can introduce this from the standpoint of analog versus DRM gradually by putting on just certain programs on DRM initially, because the transmitter can go DRM analog at the push of a button.
Okay.
And that's one of the things that we're encouraging these broadcasters to do. Because they're concerned, well, if we go DRM, we're going to have to have a new receiver. Well, as receivers are unfolding in the marketplace, you can begin to just penetrate that market gradually with certain broadcasts.
I see.
And make it a gradual transition.
If people want to find out more about Kintronic Labs, where do they go?
www.kintronic.com. And we have a brand new website that we just put up about 2 months ago.
All right.
And so we encourage people to go there and find out more about our company and what we do, because we are promoting ourselves as an RF solutions company, not just an AM radio company.
Thanks for making that clear. Of course, that's where most engineers get their experience with Kintronic Labs, is ATUs and isocouplers.
And directional antenna phasing systems.
There you go. Yep.
But I think we have positioned ourselves in the world market to be a leader in digital radio rollout. And that's what we want to do. And we're involved in projects in the Middle East and in Asia right now that are going to be significant, I think, in terms of revealing the capabilities of DRM in the future, and HD as well.
And of course, besides the big projects, if I need a new air variable capacitor for my ATU, I can still call you for that, right?
Well, no, we don't use air variable capacitors for ATUs.
Okay.
Use those in receivers.
Okay. A vacuum variable. Vacuum variable capacitor, yes.
We'll guarantee we can fix you up.
Thanks a lot, Tom. I appreciate you being here so much.
Thank you, Kurt.
All right.
I appreciate the opportunity.
Take care.
You too.
Bye-bye. Bye. You're watching This Week in Radio Tech. We are live from SMPTE in Sydney, Australia. I'm Kirk Harnack. This is episode 176. Come on in here, Jay. Jay Tyler with Wheatstone is here. Let's see. Oh, I see. This is so delayed. There you finally are. Okay, there we go. Hey, I got to ask real quickly back to Chris Tobin and maybe Andrew Zarian. Is the video coming through okay? Are we all right? Do you need to do any resets?
Pictures are looking great. The audio is fine. The guests are great. Everything is in great order.
Awesome. Good deal. Well, I've got another great guest here. This guy is like Mr. Entertainment, Mr. Good Times, and he also knows what he's talking about.
Thanks, Kurt.
It's Jay Tyler from Wheatstone. Hi.
Good. Thanks for having me. Good to see you again, Kurt.
Oftentimes, Jay and I are on opposite sides of the aisle, like Republican, Democrat, like salt and pepper,
That's right.
And but Jay's in here. You brought some show and tell, right?
Yeah. That's what we do. We're an equipment manufacturer. Yep. So I brought in an Aurora 8 IP blade, one of our IP devices that we've been doing with our WheatNet IP stuff. Okay. And I think I'd take the cover off and show the folks in the audience a little bit about the blade.
Wow. Yeah, it's a little top monitor there. It's the live one. Now, I'm seeing a lot of parts on there.
Yeah, there's about 2,100 parts in a blade.
Isn't that amazing?
Yeah,
Isn't that amazing? Here, let me have a look. Wow. Okay, so just here, tell you what, let's hold it up and go through a couple sections here. We'll give a little quick electronics lesson. Looks like the power supply is up here. Yeah?
That's right. Switch mode power supply that we design in-house. We've got a built-in headphone amp for monitoring on the front. We've got...
I think you could run some JBL speakers with that little guy.
I know, it works great. It's very reliable. But yeah, it's a great for monitoring point. This is a mixed signal blade. So you've got your analog input section here.
Okay.
You got your digital input section here.
Yep.
Your digital output AES transmitters here. and good old-fashioned 2142 socketed op amps for your analog outputs.
Okay. All right.
Yeah. In addition to the I/O, you see these handful of DSPs right here.
Okay.
These are what give us our processing. This particular blade has 8 embedded processors in it. So it's got 3 bands of compression, 3 bands of AGC, and 3 limiters. Great for headphone monitoring, streaming. One blade will replace about 8 compellers in your rack. So if you want to do some leveling, some protection for your STL on the output, they're routable, so then they're matrix, and they don't use the actual I/O on the blade. So you've got 16 in and 16 out, but these 8 processors are virtual.
That can be via the WheatNet?
Yeah, and you can patch them in anywhere you want in your signal chain.
Yeah.
So yeah, it's just one of our devices that we have in the WheatNet product line.
Very nice. You guys design these boards at your factory?
Yeah. This is it's about a 6-layer card, and what's neat about the WheatNet IP board, Kirk, is you see some unpopulated components. So depending,
I thought you guys were just getting cheap and not.
Yeah. No, but what we do is we load it specifically for the type of blade. So if this was an all analog blade, you'd see all these A to D converters right here, and you'd see all the analog output socketed. This one's 50/50. So we really have one card that we use for our I/O devices, and we load it to give it the various forms: analog, digital, or mixed signal.
I want to talk about tech for just a second. You mentioned these A to D converters, and 10, 15 years ago, A to D conversion scared engineers. Like, this is a bad thing if you do too much of it. But our company, Telos, and your company has found out that there are really high-performance AD and DA converters out there now. It's not a big issue anymore.
No, not at all. They're all 24-bit parts. We're running these things really fast, 96K. You get excellent audio performance. And as much as we want to say digital and IP and talk about it, it's still an analog world.
Well, your ears, yeah.
We've got ears, we've got microphones, but still about half the systems that go out there, I'd say they're about populated about 60%, 70% analog input still.
Sure.
So it's a necessary evil. But for you folks out there in the technology world, if you have a digital output, whether it's SPDIF or it's AES on the back of your Zephyr, you've got a mini disc with a SPDIF. Use that digital output, because one of the reasons we wanted to go digital and get into this technology was to get away from the conversion. But if you don't plan your signals right and you start wiring out everything in analog, you do have that conversion just to get it into the system to mix and route.
And that's always an opportunity for hum and buzz and things that don't happen in the digital world. But even though our AD and DA conversion electronics are now really good, there's still the possibility of things happening outside with unbalanced connections and ground loops.
That's right. And even an unbalanced SPDIF signal is going to be better than a balanced analog signal coming into your blade or your node, or even your standalone digital console. But it's twice as much wire.
Yeah.
It's twice as much punching or termination. And if you got to document it. So if you can use the AES inputs on any of your devices, use that, because we want to get away from that unnecessary conversion.
Yeah. And by the way, I have never burned my fingers with a soldering iron when installing a fiber optic,
No.
SPDIF connection.
Pretty safe.
Yeah. Well, so what are people here at the show looking at? What are they interested in your world of consoles and routing and such?
Australia and New Zealand's an interesting market. These guys this industry is way ahead of its time. Everybody here has been doing networked audio, large routers. Klotz has an incredible install base here, and so doesn't Logitech. So these guys are already in the whole routing, mixing this type of platform where we're using, virtual consoles and using boxes, whether it's TDM or IP. So these guys are actually looking for the next round, and so they're looking at the Wheatstone stuff, they're looking at the Axia stuff, Lavo's here. But our two companies pretty much right now have got a lot of buzz here because people want to leverage this Ethernet technology. They want to use off-the-shelf switches. They want to have a dynamic plant that can be changed and routable. And since these guys have been doing it, they're just looking to do more of what they've been doing for the last several years. And so there's really the learning curve, and our install base here is really good. The engineers in Australia, New Zealand, they're very technical. So it's been a great show and a good market, and lots of buzz about our new technologies.
Cool. Jay, thank you very much for stopping by. I really appreciate your time.
Great seeing you. Thanks for
Have a good rest of the show here on Casual Day. I didn't get the memo, apparently.
Yeah. Well, you always look great. Take care. See you all.
Take care, Jay. All right, we're live. That was Jay Tyler with Wheatstone. We are live at SMPTE in Sydney, Australia. And I'm Kirk Harnack. You're watching This Week in Radio Tech, brought to you by Omnia and the Omnia 9 audio processor. By the way, you might be interested in where are we in the show. Let me see if I can swing the camera around here for just a second. We're in the booth. Chris Dredge with On Air Solutions very kindly offered up his booth and his internet connection to let us connect. We're going to try to get Chris over here in just a bit to talk about what they're showing. They're a TriCaster dealer, so that's the NewTek TriCaster. They also are a dealer for LiveView, the portable uplink solution for television. WorldCast Systems, Sencor, they used to make test equipment, and now they're into all kinds of things for television. Automat, Meinberg, and Logitech, as well as a console manufacturer and a routing system manufacturer. So thanks very much to On Air Solutions for providing us with some reliable bandwidth. If you've ever been to a trade show, getting some internet bandwidth on the show floor is difficult and or expensive, and it's never cheap. It's always very expensive, and even when you pay a lot for it, you often don't get what you pay for. So On Air Solutions has done a great job with the provider here for internet. We thank them very, very much. Also, you may notice I'm using an AKG microphone here. I brought my usual Heil PR40 along with me here to Australia, but it's not a handheld microphone, and I didn't have a great place to hook up the mic arm. So last minute, the guys at AKG allowed me to borrow this microphone, so really appreciate that. Hey, let's get Goran Tomas over here. Come on in, Goran. How are you?
I'm good.
I'm going to have to aim the camera up higher. We're probably going to cut your head off here. You and I are going to have to step back a little bit from this camera. Well, look, apparently you and I can't both be in the shot at the same time.
Right. It's okay.
How tall are you?
6'4" in American units.
Now, between you and our colleague, Peter Passian, who's taller?
Oh, I don't know. We're about the same.
About the same. All right. We put a short guy at a disadvantage here. Yeah. So Goran works now with the folks at Telos. What are you doing with us anyway? Are you designing stuff?
I am. I'm working in R&D with Omnia, mostly on streaming products. And also helping our customers with the Omnia products that we have for FM. And
now you've got some expertise in coded audio, I believe, because one of the first times I ever heard your name, it had to do with you doing some research on coded audio and maybe cascading or psychoacoustical effects and such. You have some expertise there?
Yeah, it was actually research done to see how much audio processing affects coding. So yeah, we found out that you don't want to overprocess audio before encoding for streaming.
What's the bad thing that happens when you do that?
Essentially, you exaggerate the artifacts.
Okay.
Yeah, so you get a worse audio quality than you would if you processed, lightly or conservatively.
So I take it that psychoacoustic coding, we have that word psycho and acoustic, psychological acoustic coding. It depends on the audio being of a natural nature in order to do what it's supposed to do.
Yes, and if you compress it too much and if you reduce that dynamic range, then the codec really doesn't know what to throw away. And there's issues if you, for example, use your FM processor for streaming, then you actually put pressure on the high end. You put more density in the high end. And the codecs are more sensitive on the high end. You get much more artifacts on the high end. That swishing and swooshing. It's all in the highs.
How does now? Obviously, if you're streaming with linear streaming at very high bit rate, then I guess you can do whatever processing you want to.
Yeah. Then it's kind of a free lunch. You can go and.
Wow. Except the bandwidth is not free. Yeah. So here's my question: what about? We've never talked about this. What about if you're using one of these lossless encoders? Can you process hard before a lossless encoder?
Yeah, lossless is completely transparent, so it's mostly mathematical, reduction of data. It's like a zip compression. Yeah. So it's bit for bit identical input to output. So yeah,
so lossless is using no kind of psychoacoustic modeling to determine what you can hear and can't.
It's mostly mathematical redundancy in the data. So exploiting that. Therefore, the reduction you get is not so big. So it's at the most like 50%. But yeah, it is essentially it is fully transparent. It's like uncompressed. only you reduce your bandwidth a little bit at the expense of having to encode it and decode it.
Gotcha. Hey, one thing that people ask about is in some of the Omnia, in the Omnia 9, Leif Clayson has this undo technology.
Yeah.
And Leif's not here. I figure maybe you can give us a little explanation of what is this undo and how does it make audio sound better?
Well, undo actually it's combined with a declipper from Hans van Zupten. And
I met him. He's from
he's from Germany.
Oh, from Germany.
Yeah.
Okay.
But he's been at the shows, so I'm sure you've seen him. So yeah, it's a combination of a declipping, and undo is a program-dependent expander. So Leif, as a designer, was very annoyed with the processing that goes on CDs and in modern music.
Yeah, so you get a CD nowadays from almost any genre of music, and if you look at it with an oscilloscope or just import it into Audacity or something and see the waveform, it's square
it's a
waves.
brick wall. Yeah.
A brick wall.
Yeah. It is very clipped and very processed, and it has a very limited dynamic range. And it
now the question comes up from those who haven't studied audio processing. Well, if it's already processed, why not just put this on the air directly without doing further audio processing?
Well, at Omnia, we do that as well. In the Omnia 11, we have a chameleon technology that it will detect that the audio coming in is already processed. So it will not process it further. It will just pass it along too. We still have to process because there's pre-emphasis involved. So we will boost the high end and we will lose the tight peak control of the source audio. But we do have technologies that will kind of, see, oh, this is already very dense, I will not touch it too much.
But we still have to prep it for the FM transmission scheme, which
There's
involves
also stereo generation, pre-emphasis, clipping. I mean, as soon as this type of audio that's already very tightly peak controlled and clipped goes through something like an all-pass filter, all the tight peak control is lost. And we have multiband processing, so this necessarily involves crossovers and filters.
And I want to point, just because a waveform is already tightly controlled and clipped, like right off the CD, doesn't mean that it's going to match sonically other audio that has gone through multi-band processing.
Yeah.
So I don't mean to put down the record industry, but these guys are doing processing for the benefit of the transmission medium, CD or maybe iTunes distribution, that they see, but it's not appropriate necessarily for broadcast.
Exactly. It's exactly right, because we as a broadcast radio station, we want to have a consistent signature sound, that it's always has roughly the same amount of low end and high end, the way the engineer or PD, wants it to. So we essentially do re-equalize a little bit every song that comes in to a processor.
And the unique attack and release times and program dependencies on the processing that an Omnia 9, an Omnia 11, even competitive processors all do. These are all different than what processing has been done by the record mastering people.
Yes, It is a kind of a separate processing that we want to have this flow on the radio station from one song to another, to announcer, host. Everything needs to be nicely, consistent, and we don't want things to jump out, so we need to have this.
I guess what I'm saying, processing isn't processing. I mean, processing from the CD is different than processing on air.
Yeah, definitely. Yeah.
Just as an engineer might work with a processor to get a signature sound, and if all of a sudden he went to a backup processor, especially from a different manufacturer, the station wouldn't sound the same.
Yeah.
Even more so when the CD processing is just fairly simple limiting or clipping.
Yeah.
It's not going to sound like the other stuff that's on the
exactly, and a lot of problems come from the fact that producers use simple tools to process for CDs, for example.
Yeah.
So they use a lot of simple clipping, where in broadcast, in radio, we use distortion cancel clipping, which is much more sophisticated and has much better results in terms of how much distortion we put on the air.
Sure.
Sure. And these tools, these sophisticated tools, have not kind of propagated to the producers of the CDs.
Right.
So they use clipping, which may not be oversampled. They use a lot of crude stuff. Let's put it that way.
Hey, don't go away. We're gonna just stay right here. In fact, I want to get you to talk about the Omnia 9 for a minute. And after we give our sponsor message, we're going to chat a bit about this project you've been working on, MPEG Dash. Okay. I want to hear what you can say about that.
All right. Okay.
You're watching This Week in Radio Tech. I'm Kirk Harnack. We're live from the SMPTE Expo in Sydney, Australia. And our show is being brought to you by the folks at Omnia and the Omnia 9 audio processor. Hey, let's run back to the studio real quick in Queens, New York at GFQ and get some take on all that we've heard from Chris Tobin. Hey, Chris.
Hello there. Well, it's good to see Goran again. And
yeah, it is.
And you know what? Streaming and audio processing, that's the thing today. That's what everybody needs to start to understand. And he had some good points about as you pointed out, with CD distribution and iTunes, and what you do with the audio and what to expect. So it's a good refresher, because I just talked to some folks the other day about audio processing, and they were confused between over-the-air radio and what you do with streaming, and why is it so different.
So our show is being brought to you by Omnia and the Omnia 9, and good thing I chose the Omnia 9 to be today's sponsor, because we've got an Omnia 9 expert right here. Now, you didn't write the software for the Omnia 9, but you know a lot about this thing, right?
Yeah.
So what is special about the Omnia? By the way, this is the commercial, okay? So it's okay to talk commercial. What's special about the Omnia 9? What do people like about it? What are the features?
Well, maybe a good question would be what is not special about it, because everything, every part, every stage of it is really a different take on what's been available on the market. So you have the clipper and the undo, which are unique to the Omnia 9 for now. You have processing cores, which are extremely flexible. 4 to 7 bands.
Okay.
You can choose that on the fly and exchange that. And then there's this psychoacoustic composite clipper, which has been proven very clean, and very effective at clipping. So,
and is that the stereo embedder? Is that the same thing?
So a part of it is a stereo embedder that puts the pilot in and allows you to achieve, modulation, left and right modulation over 100.
This is crazy.
Yeah.
It's like going into a phone booth. Yeah, you're outside. You see the phone booth. You go inside, and all of a sudden you're in a concert hall.
Yeah.
It's like so you can modulate on the air 100% on FM modulation, and your left and right demodulated audio would be 140%, something crazy like this.
Yeah, something like that.
That's just amazing.
It is amazing. It's a very cool technology. Yeah, and for now it's unique to the Omnia 9.
Yeah.
And then there's also separate processing for your HD channels and web streaming, and I think the first processor to ever incorporate streaming codecs encoders inside the unit. So essentially, your one box can do FM processing, and then can do audio processing for HD channels 1, 2, and 3, and then have 3 additional web streams.
Do people use these actually for public web streaming or for confidence monitoring, maybe back to the studio? How are they using that encoding?
Well, for both, for a lot of applications, for both, a lot of people use them for web streaming.
Gotcha. Hey, so the Omnia 9, check it out on the website at omniaaudio.com and click on the Omnia 9. It's an awesome processor. And, people say, well, how does it fit in between, the old Omnia 6 and the Omnia 11? So it doesn't really fit in. It's not like between these things. It's a different idea.
Yeah, it is a different take on FM and web stream and HD processing. Yeah.
There are also videos on YouTube and maybe on our website too, on the Omnia site, where Leif Clayson explains some of the features here.
Yeah, definitely take a look at those, because Leif can explain the best as an inventor what was the idea behind those.
So we don't have time for a complete lesson on the next subject, but I want to know something about what is this thing MPEG Dash?
Well, essentially, streaming has gone into kind of another step. With adaptive streaming over HTTP, And the problem is that at the moment we have 3 competing technologies. We have Adobe's HLS, HTTP live streaming. We have, Apple's HLS. They have Adobe's HDS, HTTP dynamic streaming, and then we have Microsoft smooth streaming.
Now, and I should point out that the purpose of this dynamicness is to let you enjoy content, whether it's movies or songs or television, no matter what device you're using, and get the best performance for that device and that connection. So if I'm home watching Netflix on the big TV and I'm on my high-speed cable connection, I'm going to get the high bandwidth version.
You want to get a HD stream.
But if I'm mobile on 4G or even 3G and I can't stream at 2 megabits per second.
Yeah, then the player will throttle down to the bit rate that you can sustain with your device and your connection, and will give you the best quality, for the device that you have.
So there's these different technologies. What is different about MPEG Dash as one of these?
So the problem is now when a content provider wants to put some content for the viewers and to cover all potential viewers, he needs to have all 3 technologies. So he has to encode for smooth streaming and have a smooth streaming servers. He has to have an Apple's, infrastructure, and for Adobe, and that's not cost effective, and it's a fragmentation of the market. So MPEG Dash is an MPEG open standard that is supposed to unify all of these standards into one.
So it's itself not a new standard, but it's a unification framework.
Exactly. Yeah, it takes a lot from smooth streaming and from other technologies. So it's kind of the best of all the 3, and it is supposed to be one standard that will replace all the other 3. So and it's an MPEG standard. So that's kind of the beauty of it. And
now we've been talking in terms of viewing as in television, but I understand the BBC and RTL these are radio companies or radio streams are interested in the same ideas.
Yeah. I mean, MPEG Dash, as any kind of streaming, can be used for video and audio, but also for the audio only. So big broadcasters for now in Europe, like BBC and RTL from the Netherlands, are looking at using MPEG Dash. Another benefit of MPEG Dash is that it allows DRM, so it allows content protection.
Okay.
So those broadcasters are often concerned, about limiting who can view the content.
I don't know. I want everybody I can to view it. But you mean if they haven't paid for it? Yeah.
Exactly. So they want to charge or have some other type of protection. Yeah. So MPEG Dash allows that. So that's why it's interesting for those broadcasters. And it is expected, especially from the BBC and RTL, from what I understand, that streaming might eventually replace broadcaster or supplement it.
No. Yeah, I think so.
So they want to be ready. And that's why we are working with them and to coming up with a solution.
So I understand at least 1 or 2 of Telos Omnia products will incorporate this standard.
Yeah, we might have some news about that for the NAB show next year.
Okay.
So that's all I can say for now.
Goran, thank you so much for stopping by.
Kirk.
I appreciate it very much. All right, take care.
Bye-bye.
Okay, bye-bye. We're streaming live. We're doing the show live from the SMPTE Expo in Sydney, Australia. Hi, I'm Kirk Harnack, and we're going to bring in Hal Buttermore in just a moment, but Chris Tobin. So what's your take on this this MPEG Dash or other such standards for dynamic streaming?
I think it's a great idea. I think it'll help to bring more things to market, and with the DRM you can control it. It just breaks down the barriers of having 3-4 different ways to stream video and audio, how to get things out to the audience you're trying to reach. I think it has some merit. I think it's going to take a little changing of the ways everybody thinks, but I think it makes sense.
So, it seems there's several standards out there, and so MPEG Dash, what is this? What did Tolkien say? One ring to rule them all. Maybe that's where we're going with that. So we have with us here Hal Buttermore. Hi, Hal.
Hey, Kirk.
Good to see you.
You too.
You and I almost met some years ago, but I think you were out that day.
I think I was.
when I came by, and I met your colleague Ed Buterbaugh.
Correct.
Yeah, at the ABC Cap City station.
I think we had just built that facility at the time.
That was the Mitch Album studio in Detroit. Yeah.
Yeah, correct.
What a beautiful place that. Yeah.
Awesome.
Yeah. So so you have a great deal of background in radio engineering.
Yes.
And you're still involved with audio, but now it's audio for television.
Correct.
So tell me about some of the concerns. Hal works, he's my colleague. He works at our linear acoustic division.
Correct.
Doing audio processing for television. Tell me about what you're finding out as a radio engineer. What's different about audio for television? Or audio processing for television?
We're on the air, so I'll have to choose my words carefully.
Sure, okay.
In television for years, the audio portion has been considered the stepchild. Their primary focus was video, and audio was just good enough. It was okay. If it was there, it was good enough. With the advent of digital TV, the turnoff of analog television, all of a sudden the audio became a greater awareness and it became more important.
Now, is this because of home theater systems, perhaps? You got more speakers, more consumer awareness?
Basically, all the analog transmitters were shut off, and everything was digital. And you no longer had a mod monitor. You no longer had a way to even check on your audio. Many facilities didn't have any equipment in place for audio.
Okay.
Linear Acoustic is a 12-year-old company now, and our president and founder, Tim Carroll, that 12 years ago, started in earnest working on a solution for television audio like we've had in radio for many years. You've had multi-band processing for digital radio and analog for many years. Television was behind radio in that respect.
Gotcha. So for decades in television, you said it was the stepchild. Audio was a stepchild.
It was.
It's there. The speakers in TVs used to be just a little
tiny,
3-inch by 5-inch little speaker, and if it was there, and I guess when you have television, you have the visual cues as to what the performers are saying, what the dialogue is.
Right.
And in radio, we never had that. In radio, our audio always had to be the best we could possibly eke out of the system.
Right.
Now with television, and I still say, I didn't care so much about TV audio until I had a home theater with surround, but even before surround, just stereo speakers.
Yes.
I wanted it to sound good.
Absolutely.
Now, I guess with digital, we have additional problems like lip sync issues with different signal paths and such.
That's true.
Yeah. So, so linear acoustic makes these television audio processors. Tell us about how do we handle surround versus stereo when some content is produced in stereo, others surround, and we need to move it through these two different worlds.
Our upmixing is what takes care of that. Linear acoustic has upmixing that will take stereo and do a high quality upmix, and then when the network content comes through in a 5.1 configuration, it'll pass it as 5.1. If the commercials and local inserts are stereo, they're also created into a 5.1 sound field, so the viewer gets a complete 5.1 experience.
So in a stereo surround field, we have the front stereo left and right. We have the center channel typically for dialogue.
Yes.
And we have the rear channels, the surround left and surround right.
And LFE for the
and
low
the LFE for the low frequency
subwoofer.
Okay. How is upmixing? How is that technology different than just filling the other channels with audio, than just replicating the left and right audio?
In a true 5.1 mix, all the content is placed in the 5.1 sound field where it needs to be for a compelling mix. Our engineers have designed an upmixer to create from stereo a very high quality upmix.
But the feeling of a surround environment, even though you're starting with just two channels, yeah?
Yes.
Okay, that's okay. So what kind of techniques are used to do that? Is there a little bit of maybe delay applied to the rear channels?
Oh, it's proprietary.
Oh, okay, can't talk about that. Yeah, you tell me, but then you have to kill me. How about we go get a drink tonight?
Sounds good.
So now a lot of television stations are moving into proper audio processing.
Yes.
What do you find cable operators or IP television operators, are they also now concerned with this?
Well, the CALM Act in the United States, yes. Any broadcast entity is required to be compliant with their audio. Including cable operators.
So cable insertion ads are supposed to be the same level as the rest of the dialogue, yeah?
Correct.
Yeah. I don't think it's happening everywhere yet.
There's still some work to do.
Yeah. Yeah, okay. Now, another technique I'm interested in is, it seems that Linear Acoustic has a method for taking surround sound and transmitting that through a stereo transmission transport, like some kind of satellite that may just be set up for stereo. But at the other end, you can get 5.1 back out of that. Am I talking out of school here?
I think you're Dolby AC3 encoding.
Ah, okay.
Yes.
Okay. So, okay. So we start with, we have a surround mix that was produced on site, maybe, and then we can encode that in such a way that it goes through a stereo, and then at the other end, bring it back out to surround.
In a word, yes.
Okay. Maybe I'm oversimplifying.
No, yeah. It's Dolby. We work with our equipment incorporates Dolby encoding, and Dolby AC3. Other parts of the world will use Dolby Digital Plus, and we partner with Dolby and create or provide the ability for stations to utilize that technology.
There's a term that television engineers use that I'm still not exactly sure what it means. And this term is dial norm. Tell me about what dial norm is.
How much time do we have?
Oh.
Very short story. No, I don't have enough time.
Oh, okay, all right. Well, it has to do with loudness in television, yeah.
Right. It's metadata in the signal that Kirk.
We just don't have the time.
Yeah, I don't know how to explain it in this short.
We've had Tim Carroll on, and we'll have him on again. Maybe we'll take a full hour to explain
Tim wrote the book.
Dial norm. He did.
Sure.
All right, good. Hey, Hal, thanks for stopping by. I appreciate it very, very much you being here.
Yes.
All right. Hal Buttermore, who now is a colleague of mine. I never see him. This is the only time we see each other is at a convention, You're watching This Week in Radio Tech. We're live from Sydney, Australia, and the SMPTE show. And hey, Chris Tobin, can you fill in for just a second? I got one more guy to try to wrangle in here to chat with as our show continues.
Sure. Time to wrangle those guests. All right, This Week in Radio Tech, we have Kirk Harnack in Sydney, Australia, for those of you who've just tuned in or checked us out. And he's been talking with some folks in the industry, and it's been really good things. And by the way, as just a announcement for folks that are familiar with the New York metropolitan area, Conrad Troutman, CTO at Dial Global, was selected for the engineering award for the SPE chapter here in New York City, chapter 15. So I just want to send that kudos out to Conrad. And just letting everybody know what's going on there. And those of you who don't know the Society of Broadcast Engineers, if you're looking for a way to learn engineering and broadcast and technologies in general, and become familiar with standardizations and things of that sort, SPE.org. Check it out. There's a lot of things that we do as an organization, both on the national level and locally in your various cities where you may be. So check it out, and it's always good way to meet folks. So check out an SPE chapter meeting in your local area, and meet up with the engineers that are there, and some of them have lots of knowledge, so you should definitely tap into that. So,
and if
Kirk
you remember SPE, you remembered.
What's that, Kirk?
Don't vote for Pedro. Vote for Kirk.
Right, exactly. Now we'll go back to Sydney, Australia, where Kirk Harnack is on the show floor talking to someone with an orange lanyard.
And with an orange lanyard, yes. This is Chris Dredge. Hi, Chris.
How you doing?
I'm great. Thank you so much for your hospitality of letting us in your booth.
It is my pleasure.
Act like idiots.
Actually, that's a specialty of mine as well, so I'm entirely comfortable in sharing it with the world.
So, hey, I've got to get in front of the camera here. We don't have a cameraman, so... Oh, there we go. So, let's see. Well, I wanted to finish...
Actually need to crouch down a little bit, I've noticed. I'm fractionally...
Everybody's taller than me.
I'm losing my head. It's the last day.
Oh, yeah. Well, why don't we back up just a little bit?
Hey, there we go.
There we go. That's better. All right.
I'm glad we cleared that up.
To finish Chris Tobin's thought, seriously, Kirk Harnack is running for a board position on the SPE board, and I would greatly appreciate your vote when you get your ballot, either the electronic ballot or the mail-in ballot, whichever you've chosen to vote by. If you're an SPE member, please vote for me. And if you're not an SPE member, join SPE and vote for me. Thank you very much.
I think if you're an SPE member, I would vote for you.
If you were.
If I was. Question though.
Yeah.
SPE.
SPE.
I don't know what SPE is.
The Society of Broadcast Engineers.
I see. I'm in sales, unfortunately. They don't let me in.
Oh, sure we would.
Okay.
Yeah.
In that case,
yeah.
I'm going to vote for you.
And SPE is international, but it's certainly most prevalent in the U.S. And so here you have SMPTE, you have AES.
We do.
In Nashville, where I live, we have a SMPTE and AES chapter that are rather combined into one, and a few SPE members are members that they go to the other side and members of both organizations.
That makes a lot more sense to me now. But I would still vote for you.
It's like contributing money to both the Democrats and the Republicans.
Okay. So we have politics too, but nobody pays attention here.
Hedging your bets.
Absolutely,
yeah.
absolutely.
So thanks again for letting us in your stand.
It's my pleasure.
Bandwidth is hard to come by, and you've got the right amount of it.
We did know, and I believe thus far you're still on air, so we still have it too, which is an encouraging sign.
Yeah, good deal. They haven't cut you off for
not
bad content.
No, not yet. But now I'm on board. We might be in trouble, but let's see how we go.
So your company's On Air Solutions.
Indeed, it is.
Pretty descriptive name. So tell me what you do.
Look, when our solution started, we thought that On Air Solutions was a pretty good name for a broadcast company. Yeah. Clearly this is the intention. Look, we are a niche provider, so we have a couple of core products that fit particular niches. We're only about 6 people. We really tried to find hardware solutions that were best managed by somebody that could concentrate on those solutions rather than a huge range of products that we didn't know a lot about. So we've been pretty successful in that. We're about 3.5 years old. My background is 16, 17 years. I introduced Telos Omnia into Australia back in the late 90s.
Right.
And then it sort of moved on from there. So, we've all been around for a while in the industry, but, we've got a few cool products. I do need to show you this one.
Yeah, this is cool.
This is my cool one. So this is a LiveView. This is a LiveView LU40. So this is the last word in cellular bonding for news gathering or for live web streaming. So the LiveView product is, generally speaking, quite well known throughout the world. It's probably the market leader. This is their LU40. It has 4 modems and it bonds the cellular bandwidth from 4 different connections to create a single video feed.
Even if they're different providers.
Absolutely, through different providers. In fact, we strongly recommend different providers because you're using different backhauls. So you're not creating a particularly, you're not flooding a particular carrier.
Right.
They're all using different networks and behind it. So this is an amazing little product.
I've always seen LiveView as a backpack, kind of a large box.
It is. That's just a little bit heavy for me to carry both at the same time.
They put that in the Shrink-O-Matic and came out with this?
They did. Washing machine. Actually, no, but you put it on the hot cycle. It did everything you needed to do. So, and this is awesome because traditionally the news gathering was done by the bigger backpacks, whereas this one was particularly targeted at sort of news gathering, but the live to web market. So when you get it into its little pouch, it can just sit on a pouch and sit on your hip. So all you need to do is just look down. You can see your video. You can see your publishing statistics for data. Because it's cellular, those data statistics are going to change. And you know that you're on air all the time, and yet it's 2 kilos, a couple of pounds in non-metric language. So it's awesome.
Now, look, us guys in radio, we have small budgets.
Yeah.
This feels like it would pay the salary of 3 of our employees at the radio station for a year.
No, probably 4.
Yeah. 4 employees for a year.
Yeah. I've been in radio.
Kind of a spendy box.
Well, I started in radio and ended up in TV because that's pretty much the reason. But no, look, these are actually amazingly affordable. It's a little bit difficult to talk numbers because it's such an international market. It does shift from market to market, and particularly because of the data costs. So you have the joy in the United States. You have a lot of unlimited plans that are a fixed price and unlimited plans. In Australia, we don't get that. Our telecommunications guys have worked out, if you use it, we want you to pay more. And they appreciate it. We don't.
At the hotel, there's a cap at the hotel. In the States, we don't have data caps at the hotel.
Who does that? I want to go to the US just because I get unlimited Vegas, which I do in anywhere except when I go to Vegas and they charge me crazy amounts. But normally I get unlimited free anywhere in the US. So not the same in Australia, and that's reasonably common. We find around a lot of the non-North American parts of the world. So, and that unfortunately then has a direct influence on the way the pricing models work. But as a method, we know in Australia particularly, as we're rolling out 4G and you have the LTE networks, that people do live webcasts and they use a single modem and they work until they don't.
Oh, yeah.
And when they don't, you're stuffed. Can you say that is stuffed? Okay?
You can say that. Yeah, we don't know what that means in the States.
You are in. There's a variety of 4-letter words, but technically speaking, you are in trouble when your single modem solution dies. So this is all about overcoming that. You can have a busload of tourists drive by. And one carrier may struggle. Well, I've got 4.
Yeah.
I've got Wi-Fi and I've got Ethernet, and that means I've got a multiple paths, and it uses all of them at once.
Where do these plug in? Where do the USB modems plug in?
They're inside.
They're inside.
So they're inside. So you know, if you look really carefully, the camera's X-ray vision can come on right now. Right in there, we've got 4 modems.
And so the signal comes out these slots. You can beam it at somebody.
Well, if you look really carefully through glasses, you can see it right. It's a bit like your phone. But it's just it is just a modem. It's just a plug in the side of my computer, modem for your computer. Yeah. It's the way it's used that's kind of cool, and the way they monitor it, the way they, hey, Verizon, you're struggling. See, Verizon, we don't have them here, right? That's for our North American viewers. And so maybe I'm not going to let you work so hard right now because you're struggling. And Sprint, you're doing good. I'm going to give you a bit more work to do. And then when it shifts, they shift with it.
Now, at the other end of this connection, back at the TV station, you've got a pretty serious computer running to merge these streams together.
Yeah, absolutely not. So what? There's a couple of ways to go about it. Now, if we're going to go direct to the web, we try not to go back anywhere but to a cloud-based server. Now, I love the word cloud because that kind of doesn't mean much.
Tell you what I'm going to do. I'm going to pull my earpiece out. Yep. I'm going to re-aim the camera over here, and we can walk about as long as the mic cord is. I just won't have feedback at the moment from the studio. So let's do this. I'm going to move the camera a bit. We're going to point it over in this. Nope. How about over in this direction a bit more so we can look at the TriCaster? We're going to aim it down a bit. There we go. How about we just do that? There we go. All right. I'm going to do a remote from way over here. We next year, if I'm here next year or maybe the year after, we'll do a shot now. We'll do a live view.
I have nudged you out of shot.
Oh yeah. Oh, how about that? Well, we can. Oh well, I'm not that important. It's the guest. It's the guest that matters. Yeah, that's a good shot. We can stand right here in front of this guy. Okay. So hey,
beauty.
At the TV studio, or wherever you're receiving all this, where does the video come out of?
Okay, so it's fairly easy to, when we're looking in a news gathering or a link to a TV studio, it is just a server that rebuilds the stream. Because you got to remember, you're sending, pieces, that's right, you're sending.
Like a BitTorrent, right? Coming in from different places.
Absolutely, and a completely legal one at that. Yeah. So, and you need to put it back together. So it really is. It's the server is just a device that sits in your rack.
You know what? That little live view. What was it called again? The
LU40.
Oh, LU40. This is small enough to take with a video camera into an exclusive movie premiere.
I would never suggest that this is a good idea.
To your BitTorrent lair.
And I'm reasonably confident that nobody would notice you with this thumping great little black. It might be small, but you would look like you needed an operation. And I suspect that the big men with blue uniforms on may help you in your exit from said movie during that process. And
I'm sorry, I interrupted your great explanation with a silly application.
It was an excellent application, just a slightly illegal, and you would never support that unless you could get away with it.
Okay, so back at the TV station.
So back at the TV station, fundamentally, it just pops out as an SDI stream, as a video stream, out of the back of the server. And the servers are really easy to configure as a single or a double or a quad. It really comes down to how many channels does the SDI card I put in my server have? Okay. Now, again, if you want to go directly to the web and you don't need it in a TV station environment, we go through a cloud-based server. Oh. So it's an Amazon hosted receive that does a receive and sends it directly off to the web from there.
Wow. Okay. So all that smarts can be up in the cloud and then delivers to the TV station via a stream?
From the cloud, it delivers it directly to the content delivery network.
Well, whatever that would be.
That's right. In the context of a webcast, it would be from backpack to cloud to content delivery network with no interruption. And the ideal part of that is it minimizes a hardware requirement on people who are content producers, not engineers.
Gotcha.
So we want to simplify the process from being, I don't want to know that I've got a server. I don't need to keep power in my rack. I just want it to happen. And that's where the cloud server makes a huge difference. In a TV scenario, you've got people that worry about that part of it. But in a direct-to-web environment where you might have a TriCaster 8000, spectacular device, and you may produce, but you just want to distribute it, this is the way to go.
So can I get the 2-minute overview of the TriCaster? That looks awesome.
I think it's nearly impossible to give a 2-minute overview, and because I'm a sales background, I can't do anything in 2 minutes, but I will try.
Okay.
TriCaster 8000 is very simple. 8 inputs, camera, 2 onboard video players, 2 network inputs, 2 graphics inputs, and 8 virtual sets. Now, the TriCaster 8000 differentiates from the 855 455 series by having 4 levels of mix effect re-entry.
Oh.
So that's a huge number of graphics on graphics on graphics.
Is that all this pretty stuff over here?
Please don't ask me to show you how it works, because we have people that know that.
Yeah.
And they are people who are very, very clever. But yes, essentially what this allows us to do, and the 8000 can do, so graphic on graphic, it can do a hotspot. So you can be on a green screen on a virtual set with a colored card and a hotspot, and it's powerful enough. All of that in a 4RU chassis.
That box there.
That little box down there. So we own this. We're a distributor as well, but we've built this into a rental pack, so our screens fold together, custom cases. Check out the New Tech forums if you're interested. We posted the pictures on there as well. So, so we built this into a custom case, but as a flyaway kit, this is getting up there in the power of a small OB truck in what we've got here. And then you pair that with a live view unit, and you've now got full production, full graphics, full virtual sets if you need them, video play out, audio management on board, and then the delivery via the live view. You know, you've got everything you need.
Yeah, I see the representation of meters here. Is there, and there's a mixer implied.
Absolutely.
There.
So the mixer's on board. It can have, you can use the audio off the SDI. You can use your audio from the XLR inputs on the back, and you can have a microphone plugged directly into the back. So it really gives you everything you need in order to do a full multi-camera production.
Cool. We're about out of time. Chris,
my pleasure.
Thank you so much. I appreciate it. On Air Solutions in Australia. If you need what they've got, give them a call.
Indeed, and enjoy my bandwidth for the next few minutes.
Did you have a website?
www.onair.com.au.
There you go.
I know.
Good deal.
Thanks very much.
Thanks again, Chris. You've been watching This Week in Radio Tech. I'll get myself back wired here again. Woo! I guess the hour's kind of flown by. Our show's been brought to you by the Omnia 9. If you want to know more about that audio processor, go to the web, to omniaaudio.com. I believe it's /9, or just click on it from the main page. We've been broadcasting live from SMPTE, the Society of Motion Picture and Television Engineers Expo in Sydney, Australia. Had a great time here. And by the way, thanks to Andrew Zarian for fixing our video. Normally we'd be upside down because we are south of the equator, but Andrew was able to right us, so it all matched up and looked really good. And Chris, you're looking fine there too. You guys getting ready to go out and have a little dinner?
Absolutely. We have the traditional drinking fest and eating, of course. And also, when you're in the hotel there, I want to know if it's true. Does the toilet turn the other way when you flush it?
I'll look for that.
Come on, those old jokes you used to hear about.
Normally, when I'm done using the toilet, I don't want to look at the toilet. Maybe I'll just flush.
Just go in and flush it.
Yeah, I'll do that.
So you're at Darling Harbor? Is that the?
Yes, Darling. I am at Darling Harbor.
Okay.
I found out a few interesting phrases and words that they say here.
Oh, there's
quite
some
a bit in Australia. Yeah, I'm getting used to them saying, "Hey, do you want to get together about 8:15 for brekkie?"
Yeah, my wife and her friends enjoyed some time in Sydney and they over in New Zealand as well. So she said it was a good time.
And at Christmas time, you give each other prezzies.
Prezzies.
Not presents, but prezzies. Yeah.
Jeez.
And they never say the word afternoon. It's always Arvo. Why don't you come by this Arvo?
Oh, I've never heard that one. Okay, that's a good one.
Arvo. Yesterday we were testing the bandwidth here. I came by in the morning, and Chris Dredge says, come by this Arvo after 4 and we'll test the bandwidth.
And you're asking, does that come in a 16 ounce or 22 ounce or 16 milliliter? What?
And then the other interesting word that they say is sometimes they'll instead of saying as just a word of affection, instead of saying darling, they'll say darl. Oh yes, darl.
Interesting. I always love traveling and finding out new things like that. That's fun.
But the way people talk is certainly interesting. Oh, and here's the other thing. So many of our dealers are a Telos dealer in the UK, in New Zealand, same one here in Australia. Whenever they're referring to accessories or the things that go along with the main item, it's always bits and pieces. Oh, yeah, we're going to get an Axia console and some bits and pieces.
Absolutely.
Bits and pieces.
I have run into that. Yeah, you're absolutely right.
And now I know what it means, but it just sounds so odd to hear that from the beginning. Hey, it's been a great show. I've had a great time. I hope we haven't lost too many viewers from just all the fun we've had here and the interviews. It's not been a technology teaching show as much, but interviews with folks who either sell technology, develop technology, know about technology. And thank you for watching. We'll be back, I guess, in studio next week for another edition of This Week in Radio Tech. Thanks again to Andrew Zarian and the GFQ Network for all your entertainment needs. You really don't have anywhere to go. I mean, the big networks, forget that. Just check out Andrew's podcast, videocasts. He's got a great variety of subjects and stuff that you didn't know you were interested in until you tuned in and downloaded and watched. So make the GFQ Network, gfqnetwork.com, a bookmark on your browser and get there often. There's also apps for the Roku box. You can get the GFQ app for that and watch. Hey, maybe Andrew could fill me in. Andrew, where else is GFQ available? Where else will I find your shows?
On iOS and Android.
Ah, okay. So there's an app for that?
There's an app for that.
Awesome.
Bandwidth here is real expensive. I'm going to wait till I get back to the States to watch.
You've been watching This Week in Radio Tech, brought to you by Omnia Audio. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.
That's all the bandwidth we can pilfer this week. Another tort has propagated, and all the transmitters and audio equipment live happily ever after, thanks to the handsome engineer and his kind, benevolent care. We'll be back next week.
Lord willing and the creek don't rise.
This Week in Radio Tech. Subscribe to iTunes and you'll never miss a show. Search for This Week in Radio Tech in the iTunes Store. Soliciting is strictly encouraged. If you like today's show, tell a friend. If you didn't like it, we were never here. Kirk Harnack's wardrobe provided by the Salvation Army and the Red Cross Disaster Relief Services. Hair and makeup provided by Penelope Garcia Hernandez Weinberg.
He's unique, wouldn't you say?
I just want to get it over with.
This ends this transmission. Tango, Whiskey, India, Romeo, Tango. Signing off. Okay.